In this presentation, we will consider one more problem on recursion. So let's get started. Consider the following C function. Here is a C function available in front of you. Inside this function, I have declared one variable x and I'm initializing it to value 1, and I have declared one more variable k, and after these declarations, we have one if construct, and inside this if construct, I'm checking this condition. Is n is equals to 1 or not? If it is equals to 1, then we will return value of x. Otherwise, we will simply run this for loop, which runs from 1 to n minus 1, right? And inside this for loop, we have one statement, x equals to x plus fun k into fun n minus k. We are simply calling fun function again, that is why it is a recursive procedure. And finally, we will return the value of x. You need to determine the return value of fun5. So is it going to be A, 0? Is it B, 26? Is it C, 51? Or is it D, 71? This question has been asked in GATE 2015, set 2. I would encourage you to please pause the video for a while and try to answer this question on your own. I hope you're done. Okay, let's dive into the solution now. I have written this function over here for the sake of simulation so that we would be able to understand what is going to be the output for this function. Although this function seems to be quite complicated, but there is one trick which helps you to calculate the output of this function very easily. As we need to know the output of this function for n equals to 5, therefore we are calling fun5 only. As n is equals to 5, this condition will not satisfy. Therefore, we will run this for loop from 1 to 4. This means we will run this for loop 4 times. And this simply means we are executing this statement 4 times. And then finally, we are returning the value of x. Now what is this x depicts? This x is nothing but the output of this function, right? This means this is the output of fun5. After execution of this for loop, this x will contain some value. And this value is finally returned back to the caller of fun5. So this means this is the output of fun5, right? Okay, so this thing is clear. Now the main thing that we need to understand is this for loop. This for loop executes from 1 to 4. So for the first iteration, that is when k is equals to 1, we are executing this statement x equals to x plus fun k into fun n minus k. I can write this statement as x equals to 1 plus fun1 into fun4, because x is equals to 1 initially. K is also 1 and n minus k will be 4 because n is 5 and k is 1. 5 minus 1 is equals to 4. Therefore, I can write x as 1 plus fun1 into fun4. But what is x? X is the output of fun5. Therefore, I can finally say that fun5 is equals to 1 plus fun1 into fun4. Now what will happen in the second iteration? That is when k becomes 2. As 2 is also less than n condition is satisfied, we will enter inside this for loop, right? Again we will execute this statement. Instead of this x, I can write this whole statement. And then after that, we just have to add this whole statement, right? So what I need to do is, I just have to know what will be fun k into fun n minus k in the second iteration. And I will simply add this statement to this statement, right? As k is equals to 2 in the second iteration, therefore this statement will be equal to fun2 into fun3, right? And I'm simply adding this statement to this whole statement. That is, fun2 into fun3 will be added to this whole statement. Now this is the current value of x, right? In the third iteration, this k will become 3 and this will become 2 because 5 minus 3 is 2. And I have to add this whole statement from here to here to this whole statement, because previous value of x is equals to 1 plus fun1 into fun4 plus fun2 into fun3. And I have to add this whole statement to this whole statement. So I can clearly say that the new value of x in the third iteration will be 1 plus fun1 into fun4 plus fun2 into fun3 plus fun3 into fun2. And now for the last iteration, that is when k is equals to 4, We have to add fun4 into fun1 because 5 minus 4 is equals to 1. Therefore, we will simply add fun4 into fun1 to this whole statement. So we can say that the final value of x will be 1 plus fun1 into fun4 plus fun2 into fun3 plus fun3 into fun2 plus fun4 into fun1. This is going to be the output of fun5. I'm simply mentioning these functions and I'm not mentioning the values they returned. There is a reason behind that. We can simplify this statement to this statement. 1 plus 2 into fun1 into fun4 plus fun2 into fun3. As you can see, there is a repetition of fun1 into fun4 and there is a repetition of fun2 into fun3. That is why I can write this whole statement as 1 plus 2 into fun1 into fun4 plus fun2 into fun3. What is the value of fun1? In this case, n is equals to 1. This condition will definitely satisfy, right? And it will return value x, which is equals to 1. Therefore, I can say that fun1 is nothing but 1 only. So I can write this statement as 1 plus 2 into fun4 plus fun2 into fun3. Now this statement is what we need to evaluate next. Let's first evaluate what this function will return, that is fun2. As n is equals to 2 and this condition is not satisfied, therefore we will run this for loop from 1 to 1, right? That means this loop will run only one time. And as we know, the output of fun2 will be the value of x, right? Let's evaluate this statement for k equals to 1. This x will be equal to 1 plus fun1 into fun1 because n is equals to 2 and 2 minus 1 is 1. So we can write fun2 as 1 plus fun1 into fun1 because the output of x is equals to the output of fun2. I can write fun2 as 1 plus fun1 into fun1 and this loop runs only one time. Therefore, this is going to be the output for this function. We know the value of fun1. Fun1 is equals to 1. Therefore, we can say that this statement is equals to 1 plus 1 and 1 plus 1 is equals to 2. So the final value returned by this function is 2 and I can replace this statement by 2. Now let's evaluate what is the output of fun3. In fun3, n is equals to 3. Again, this condition is not satisfied. Therefore, we have to run this for loop from 1 to 2. This means this loop will run 2 times. In the first iteration, x will contain 1 plus fun1 into fun2, right? So I can say that fun3 is equals to 1 plus fun1 into fun2. But as this loop run 2 times, therefore we need to evaluate this statement once again. And this means we just have to add this statement to this whole statement, right? This time k is equals to 2, therefore we have to call fun2 and n minus k is equals to 1. Therefore we can say that this is equals to fun2 into fun1. So this becomes 1 plus fun1 into fun2 plus fun2 into fun1. We already know the value of fun2 and fun1. So I can write this statement as 1 plus 2 plus 2, which is equals to 5. So the value returned by fun3 will be 5. After this, we need to evaluate what is going to be fun4. In fun4, n is equals to 4, right? And this condition is not satisfied. Therefore, we will run this loop from 1 to 3. That means this loop will run 3 times. In the first iteration, the output will be 1 plus fun1 into fun3. After this, in the second iteration, k will be 2 and this will be 4 minus 2, which is equals to 2. So I just have to add this whole statement to the previous statement, right? So now the current statement is 1 plus fun1 into fun3 plus fun2 into fun2. And in the third iteration, k becomes 3. Therefore, this will be fun3 into fun1. So I can add this fun3 into fun1 to this whole statement. So this becomes 1 plus fun1 into fun3 plus fun2 into fun2 plus fun3 into fun1. I already know the value of fun3, I already know the value of fun2, and I already know the value of fun1. So I can replace all these functions with their values. So the new statement will be 1 plus 5 plus 4 plus 5, which is equals to 15, right? So I can replace this fun4 by 15. So finally I know all these values, right? So what is going to be the final result? 2 into 5 is 10 and 10 plus 15 is 25. 25 into 2 is 50 and 50 plus 1 is 51. Therefore, the value returned by fun 5 is 51. So the correct option is option C, 51.